College is good for a lot of things, but one of the things that it didn't do for me was teach me how to code effectively. I got really good at making stuff work, but the techniques I was using were inefficient, and I was definitely not writing clean code. So here's 5 ways to write better code that I wish I knew back in college, and how to do it in less time. One of the most commonly thrown around acronyms in software engineering is DRY. Don't repeat yourself. And DRY is a great reminder to not duplicate logic. Instead of copy pasting something 5 times, maybe you could just write a helper method for it. And while I think DRY is a great framework to keep in mind when you're developing software, there's another lesser known acronym that goes along with it nicely: WET. Write everything twice. On the surface, this sounds counterintuitive, especially when compared to DRY. The main issue WET is trying to address doesn't inherently have anything to do with only writing your code twice. It's about not building the wrong abstractions by trying to optimize your code too soon. The first time that I write a piece of code that's pretty similar to another piece of logic, it's tempting to immediately jump on that and find a way to build an abstraction to avoid that repetition. But soon enough, you might have a third case that's pretty similar to the first 2, but just a little bit different. So you update your abstraction, you add some special casing, and now that third instance fits along with the first 2. But then maybe it happens a 4th time, or a 5th time, or a 6th time, and at a certain point you realize that what was once a nice, neat method has become increasingly complicated as you try to keep fitting more and more things into this existing model. And maybe what you realize is that that model doesn't really fit all of those things and you didn't build the right abstraction, or maybe there shouldn't have been an abstraction at all. With WET, or at least the way that I loosely follow it, I wait to build my abstractions until it makes sense. In the short term, this probably means that you'll have some extra duplicated code, which feels wrong. But if you later realize that a bunch of code is following a shared pattern and you just keep copy pasting that logic over and over again, at that point it'll feel really natural to build an abstraction for it. So definitely follow DRY if you hadn't already heard of it, but don't forget about WET the next time you're trying to overgeneralize things too soon in the process. This is a piece of advice that I have come back to time and time again. Especially when you're working on something that's fairly complicated, it's really easy to go straight into the weeds of trying to find the perfect solution, complete with lots of abstractions and patterns. I think the second and third parts of this are significantly less important than the first part, which is just the sheer importance of making the code work. It doesn't matter if it's performant or if it's pretty, if it doesn't work. Now, you shouldn't be intentionally trying to make something that's unreadable and slow, but when I'm building a prototype for something and I'm just trying to get it to light up, it's a lot easier to go from something that works and then incrementally making it better than trying to, on the very first try, make something perfect. And in terms of prioritizing performance over readability, I actually think that depends a lot on your use case. There's a lot of things that aren't that performance sensitive and don't need intensive optimization to get to a point where they're good enough for whatever they're trying to do, and making sure that something is readable and easy to maintain is the most important thing. But there are other applications where performance is critical, and any more performance that you can eke out of something is your number 1 priority. And in those cases, you should still make sure that something is readable and maintainable, but getting it fast is the number 1 priority after you get it working. Either way, that's not the point. Make the code work, then worry about the other 2. One of the other most commonly thrown around acronyms in software development is SOLID. Now, I'm not going to go into what all of the letters in that acronym stand for in this video, but if you've never heard of SOLID, I would definitely recommend looking into it. The S in SOLID stands for single responsibility, and that's the one that I want to highlight here. The importance of designing your application such that every piece is, for the most part, having a single responsibility. Now, to be fair, I actually did learn about this back in college as early as my sophomore year, but if I look back at the code that I was writing at the time, I definitely didn't get it. Designing your app with single responsibility in mind makes it much more readable, it makes it easier to debug, and it makes it easier to test. Each method can have a name that concisely describes it. It's gonna be a lot easier to debug if every method only does one thing, as opposed to having a method that has half of your project's logic crammed into it. And it's gonna be really easy to unit test all of your functionality if each method is only doing that one thing. I think that last point is the one that most went over my head when I was in college, because I never wrote test code before I graduated. But if you have separate methods for A, B, and C, then it's very easy to unit test all of them separately, and you'll immediately be able to tell if you have a regression in any of them. And you could consider this as a fun little bonus point. If you're not already writing test code, start writing tests. One of the biggest tips that I would give any developer who is looking to improve their velocity is to really learn your tools, and potentially the most important tool is your debugger. None of us can always write perfect code on the first try, and even if you think you can, you're probably working with other people who can't. Debugging can take a huge amount of time. You can spend days trying to narrow down a tricky bug, and knowing how to use your debugger really well can make this a lot less painful and go significantly faster. Regardless of what debugger you're using, invest time into learning it really well. Watching a 2-hour deep dive into all of its nuances will probably end up saving you several days of banging your head against a wall because you'll be able to diagnose your problems that much faster. This is the one point that college not only didn't teach me, it actively pushed me in the opposite direction, which is great for the sake of learning, but super impractical in the real world. Every line of code you write is a liability. It needs to be maintained, it's a risk of bugs, it takes dev hours. So why not rely on some of the amazing code that other developers have already written, instead of always writing everything from scratch? The most glaring example of this that I've seen in myself and in other devs is rolling your own data structures or rewriting standard algorithms. The reality is that for most developers, you are not going to write a better implementation of something than what's considered the standard for that language. Libraries, specifically from reputable sources, can be an amazing way to integrate well-maintained and efficient code into your codebase without a whole lot of effort. It saves you the time of needing to write your own implementation, it's probably going to be more efficient and less likely to have bugs, and it also means that any developers that you're working with don't need to learn your custom implementation of something that they're probably already familiar with. Obviously, there's still a lot of code that you need to write from scratch. That's what I do every day at my job. But when you have the chance to use something that already exists and is from a reputable source, you probably should. Anyways, hopefully some of those tips were useful. If you want to see more, let me know and I can make a part 2 to this video. Anyways, that's it. Thanks so much for watching, and I'll catch you guys in the next one.